The robin on your fence post is not resting, it is reading you. Not metaphorically, not in the loose poetic sense that nature writers use when they want to sound profound. In a precise, measurable, neurologically documented sense, that bird is processing your face, your gait, the rhythm of your movement, and the specific frequency of your voice. And it is filing all of that into a memory system that will retain it for years. What you experience as a casual glance from a small animal is, in neurobiological reality, a high-resolution scan, conducted by a visual processor that makes your own eyes look almost pathetically limited. This is where the story begins. Not with the bird, with your eyes, and everything they cannot see. The human visual system operates across a narrow band of electromagnetic radiation, roughly 380 to 700 nanometers. We experience this range as the full color spectrum, violet through red, and for most of human history, we assumed this was it, the whole spectrum, the real one. We built our entire understanding of beauty, camouflage, mating display, and ecological signaling around what our free cone cells could detect. The problem, discovered gradually through the latter decades of the 20th century and confirmed with increasing precision since, is that birds have 4 types of cone cells. Their 4th cone extends perception deep into the ultraviolet range, registering wavelengths between 300 and 380 nanometers that are, for us, simply absent. Not blurry, not dim, completely invisible. The world your backyard bird inhabits is not a variation of your world. It is a fundamentally different one, built from information you have never had access to. A 1998 study published in the journal Nature demonstrated that many common songbird species, including species you likely see every single day, display ultraviolet reflective plumage patterns that are entirely invisible to human observers. What appears to us as a uniformly brown house sparrow is, under full avian perception, covered in distinct, structured patterning, markings that communicate social status, reproductive fitness, and individual identity across the flock. The birds are not seeing each other the way you see them. They are seeing each other the way you might see a photograph revealed suddenly in a dark room. Details emerging that were always there but completely hidden to an inadequate instrument. Every feeder in every suburban backyard in North America is, from a bird's perspective, a social arena broadcasting information on frequencies you cannot read. And their eyes are doing something else, something you have almost certainly never considered. Unlike the human eye, which requires constant, rapid, involuntary movement called saccades to build a stable visual image, bird eyes are largely fixed in their skulls. Most species cannot move their eyes independently at all. They compensate by moving their entire head, and that compensation has driven an optical architecture radically different from our own. Many songbirds have eyes positioned laterally, giving them monocular fields exceeding 150 degrees on each side and a total visual field approaching 340 degrees. They do not have blind spots in any functional sense, while you have a small but real gap in your visual field, a specific point on your retina with no photoreceptors whatsoever. A bird sitting 12 feet away on your fence is monitoring virtually the entire environment simultaneously, including movements behind its own head. You cannot sneak up on it. You cannot approach without being seen. In every interaction you have ever had with a bird, the bird knew you were coming long before you were aware of it. But vision is only the beginning of what makes this genuinely unsettling. In 2011, researchers at the University of Washington published findings from a 7-year study on American crows and their capacity for facial recognition. Led by Dr. Sean Marzoff, the study had researchers wearing specific masks while trapping and banding wild crows in urban environments. The crows, once released, immediately associated those specific faces with threat. They began scolding individuals wearing those masks on sight. From distances exceeding 100 feet, they recruited other crows, birds that had never been trapped, to join the scolding. That behavioral pattern spread through the population. 5 years after the original trapping events, the threat response had not diminished. In some cases, it had intensified. When the research team wore the threatening masks while walking across campus, they were followed and scolded by birds born after the original incident. Birds who had learned the face not through direct experience, but through social transmission. The birds were teaching each other who to fear, and they were using human faces as the identifying data. You may have thought you were a neutral presence in your neighborhood's ecology. The birds have formed a more specific opinion. This capacity recognizing and remembering individual humans, transmitting that recognition socially, maintaining it across years requires a type of cognitive infrastructure that biologists spent decades assuming birds simply did not possess. The assumption was architectural. Birds have small brains. Small brains mean limited cognition. It was a reasonable inference, and it was wrong. The error came from measuring brain size relative to body mass, and then assuming that primate-style cortical layering was the only structure capable of producing sophisticated thought. What neuroscientists discovered, particularly after a landmark 2004 international consortium reclassify avian brain anatomy, is that birds possess a structure called the nidopallium caudolaterale, a region that performs cognitive functions analogous to the mammalian prefrontal cortex, but organized in a completely different architectural form, a different solution to the same computational problem. Thingvers and parrots pack neuron densities into their forebrains that rival primates, concentrated rather than spread across a large cortical surface. The brain is small, the processing is not. When a crow on your street tilts its head and watches you unlock your car, it is not doing so reflexively. It is doing so with a cognitive apparatus capable of forming behavioral predictions, updating probabilistic models, and storing outcomes in a memory septum that will actively influence its behavior toward you for years. You are being profiled. Now consider what happens to that information after you walk inside. Research on alarm call communication among songbirds has moved well beyond simple danger signals. A 2005 study by Dr. Christopher Templeton at the University of Washington demonstrated that black-capped chickadees produce structurally distinct alarm calls depending on the type, size, and behavior of predators. The number of D notes appended to the call encodes threat level precisely. A flying hawk, fast-moving, high overhead, difficult to evade, produces a short, high-pitched response. A perched owl, slow-moving but capable of striking from a precise position, triggers a call with significantly more D notes. Other species in the area, including nuthatches and titmice, decode these signals accurately and respond appropriately without ever seeing the threat directly. The birds in your yard are not simply reacting to the same events you observe. They are exchanging structured information about those events in a real-time communication system that spans your entire neighborhood. When something unusual enters that system, a new predator, an unfamiliar human, a disruption in established patterns, the network responds. And because you are a regular feature of that landscape, your presence, your schedule, your behavior, and any deviations from it are not going unnoticed. They are data points in an active biological network that has been processing your neighborhood's ecology continuously for millions of years. The ultraviolet light refracting off your roof tiles, the magnetic field lines threading through your garden, the polarized light patterns shifting across the sky above your street, patterns that birds use for navigational calibration on overcast days when neither stars nor sun are available. These are information streams you cannot access with any unassisted human sense. You are embedded in a sensory environment you are almost entirely blind to. In 2019, researchers confirmed behavioral evidence for quantum-level magnetoreception in European robins, building on earlier work by the Wiltco laboratory in Frankfurt. The mechanism appears to involve cryptochrome proteins in the retina that respond to Earth's magnetic field through quantum entanglement effects. Think the bird literally sees magnetism overlaid on its visual field as a navigational pattern. This is not metaphor. This is a sensory channel operating on quantum mechanical principles inside the eye of a bird that may be sitting on your garden wall right now. Your garden wall, which you walk past every morning without looking up. There is a species in your neighborhood, whatever it is, wherever you live, that has been adapting to the specific ecology of your street, your habits, and your neighbor's habits for longer than your house has existed. It knows the schedule of your feeders, the timing of your trash collection, the territorial boundaries of the cats on your block, and the specific human faces associated with threat versus neutrality versus reliable food. It is not passive background scenery. It is paying attention. The question worth sitting with is not whether birds have rich inner lives, or whether they deserve more credit than we give them. Those are comfortable questions. They keep the subject at a safe intellectual distance. The real question is more immediate. If a bird on your street can recognize your face, remember your behavior, communicate your presence to others, and perceive you across multiple sensory dimensions you cannot reciprocate, what does it mean that you have been moving through this shared environment your entire life, under the assumption that you are not being watched? Think back to the last time you stood in your backyard and a bird stopped moving, not flew away, stopped, and looked directly at you. What were you actually looking at? And more specifically, is there a particular bird in your neighborhood on a specific wire, a specific fence post, a specific branch, that always seems to be there when you step outside? One that stops what it's doing and orients toward you with that particular stillness. I think you already know the one I mean.